Well, thank you all for being with me today. My name is Mike Kahn. I'm going to be talking about accelerating time to value for data today. This is a great topic because really everyone that has a hand in data projects is responsible with delivering and returning results and connecting with the business. And there's a lot of patterns, frameworks, and pitfalls and anti-patterns associated with that. So when I was thinking of a session title that would be catchy and interesting to write about and put a presentation together about, I thought about this one. And then I thought about, wait a second, this could be a dangerous topic to talk about because it can be very problematic trying to do this. There's no easy button for accelerating the time to value of data. Every company, every enterprise has a ton of data today. We all are aware of that. That's why we're here to talk about it. But there are some ways to do just that, accelerate the time to value of data and get quicker to insights and get quicker to set up. So we'll go over that today. Again, my name is Mike Kahn. I work for a company called Databricks. I just moved over to Databricks last month. I manage a field engineering team, solution architects, typically pre-sales. So we see a lot of customer problems and challenges and help them get through them and make new revenue streams and solve problems and do more with their data. Before Databricks, I was with a company called Google in the Google Cloud division. I was there for about 7 years in a similar role. The role at Google was called customer engineering. And I was there about 6 months and 6 years and about 11 months. And I did the same thing there. Helped customers with their biggest infrastructure and data challenges and helped them kind of figure out GenAI last year. And I've been making a pivot towards data for a while. I started my career focusing on infrastructure and data centers. And when Kubernetes came around, I said, wow, wait a second. I'm not sure if I want to go in this direction. So I started working on different data projects at Google, and here I am. And I'm very happy to be in this space. There's so much going on with data and AI, and a really lot of work to do for all of us here. So I want to start with an overview of what we'll talk about today. As I mentioned earlier, it's risky to accelerate some parts of the data process and process that we'll go over today. Definitely has to be well thought out in some sort of order and most importantly with standards. A couple things that I've noticed over the last couple of years is that companies, enterprises get vendor lock-in. I've also noticed that most enterprises change like a cloud vendor or a software vendor every 3 to 5 years, and that's typically just based on contracts they're assigned to save money and to procure products. But a lot of companies still have challenges with build versus buy, and then measuring the level of effort and benefit of adopting software or cloud. So we'll talk about that today. Prioritization as well. A lot of companies still, believe it or not, have issues attaching like an actual business problem that they're solving for with the data. So we'll talk about data strategy a little bit and aligning data initiatives with like real problems so there can be more value delivered to the business. Because we're not here to just play with data and see what like fun insights that we're getting out of it. Ultimately, we all want to deliver value to our companies and take the credit for it and get promoted and do all these great things for our companies. Well, I'll go over some frameworks and some patterns, and then we'll talk about making progress. And hopefully, there'll be some takeaways here for you all to bring back to your careers and jobs and things that you're doing. So I like to start off with like a room check just to gauge where everyone is out there, different roles. So by a show of hands, developers in the room? A couple developers. Analysts, engineers, data scientists? Okay. Sales people, account executives? Not zero salespeople, great. Managers, directors covering data, VP projects, yep. Okay. Any executives, CIOs, CDOs? Okay, that's fine. Consultants, ISVs, great. Partners, anyone in roles that I didn't mention? Okay. What's that? What is that?
Well, business analyst?
sorry, business analyst. Very important role that I left off there. Should have put that next to analyst and engineer. Okay, great. All right, one more room check. Who in this room has experience working with Databricks? Anyone? A couple people, great. How about Snowflake? Okay. Google, BigQuery? One BigQuery? 1.5, 2. AWS data products? Yep. Cloudera? Oracle? Open source? Yeah. Hadoop? Spark? Legacy stuff? Anything I didn't cover that's consuming a lot of your time? It's pretty much the landscape. That's good. That's pretty similar to the market breakdown, the distribution in this room. A lot of people with Snowflake, a lot of people on AWS, Oracle, obviously, little bit BigQuery. So that's good to know. Thank you. Okay, so again, today, this talk will help you identify where you are with the project. We'll go over some concepts and some ideas to expedite, hopefully some parts of the process that you're working on and to give you some value and some value to employers. So here's the agenda. We'll talk about the opportunity at hand, talk about some trends in the industry. I'll talk about a process that I put together that's around getting value from data, some accelerators and some anti-patterns, and then ultimately some frameworks and architectures. So a lot of tech executives like to say every company will be a data and AI company. Like I think Jensen, the NVIDIA CEO, said that recently. A lot of the big tech CEOs say that. And I don't know if it's the case for small, medium businesses, but for many enterprises, it's very critical to have a data strategy. And most major enterprises today do have a good working data strategy. And are beginning to use data to their advantage to get a market advantage or to make money or to optimize. So that's the opportunity ahead for every enterprise and most companies these days, even smaller companies, mostly digital natives, but traditional companies are also recognizing this as well. So time to value. Everyone's probably heard of time to value, but why is it important in context of data? Everyone wants a quick return on their investment. I don't know if anyone else noticed anything, but after last year and post-pandemic with potential recession, it seems like every company is kind of like tightening the belt in terms of expenses, cutting back in terms of staff. So you better believe that if you're working on a data project, you want to have some clearly defined value that you're delivering to the organization. And if you don't, you should ask the questions and kind of figure out what that is, because being in big tech, a lot of layoffs last year, a lot of people lost their jobs, a lot of people had to change roles. Every company wants a quick return on their investment. Furthermore, with time to value is when, as consumers and as individual users, we have a high standard now with a customer experience. And then companies that are delivering customer experience want to continue to improve their customer experience. So obviously, GenAI is doing a lot of things in certain industries and certain applications with customer experience, but that needs to continue. So you can think of time to value as a KPI, a goal to hit, and it's a measurement for how quickly you can turn around and get value from data projects. So we all want these things, right? We want these things in our personal life. We want these things in our professional life. Customer satisfaction, competitive advantage over our peers, over businesses in our market, more revenue, more money, optimization of resources, improvement, innovation, and risk mitigation. These are all things that we need to do as individuals and our companies need to do as well. So that's further why time to value is important with data. Faster decision making, reduce costs, increased return on investment. Again, money, 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 right? We're working with data, and the end game is hopefully our companies carve out a new product with data. Hopefully they have enough sustainable advantage in their market that they can continue being profitable. But data is the lifeblood of AI, and you better believe that companies are looking at data projects with a revenue target or an optimization target in mind. Respond to market changes earlier. Super competitive in almost every market, especially working with customers at Google, everyone wants to get an edge up on their competitors. And the way that most enterprises are doing that today is with data projects. So this is a really interesting graph that I ripped off of a presentation. And it kind of shows the start to end, like the utopia curve, basically. So most of the customers that I work with, traditional customers that are not digital native, their data is siloed. For example, I worked with a medical imaging company last year, and entirely SQL Server. Everything is dumping into SQL Server. They don't have an actual data warehouse. It's taken them a year and a half to do a data warehouse project with a partner, and they still haven't moved forward with it. Their data is just completely siloed in SQL Server and different Oracle databases across their enterprise. So this is the case for more companies and enterprises than you would imagine. So in order to get a competitive advantage and in order to fully leverage and see the benefits of data, you have to get past that. Number one, get all of your data out of those silos, get them into a data warehouse, a data lake, or data mart, improve the situation. But then the next step is, how is data driving the business? And this is kind of where the process and the blueprint of having an actual data strategy and understanding the value that the data is providing happens. And that's where companies are becoming data forward. That's when data is integrated in every line of business in each company, and there's not a single data stakeholder, like a chief data officer or CTO. Every executive has a role in crafting a data strategy and has involvement. Because it's not just finance, optimizing costs, data, it's also technology, it's also other executives. So the role of data teams is definitely changing. And traditionally, you would have data teams reporting to a CFO, again, doing forecasting work, doing regression analysis, doing numbers work. And then you saw more data teams reporting up to marketing, trying to do marketing analytics, try to get better return off of the ad spend, and things like this. As I mentioned, moving forward, what we're starting to see is more data product thinking across enterprises and more data teams, more decentralized across the business. So every executive in most modern companies now has a charter. What are you doing with data for your priorities? How is data fueling new products? How is data fueling optimization with your OKRs and your specific goals for the year? And most executives are tied to a revenue growth number in most companies. So how are they going to grow revenue? How are they going to create new revenue streams? They're going to need insights from data in order to do that. So that's why data is definitely, it's changing in terms of how enterprises are starting to look at data. So there's a couple of different value concepts that I'll talk about in this presentation, but I thought this one was very interesting. It's called the value pyramid model, and usually starts on the bottom left-hand corner with data teams and data challenges, goes up through the lines of businesses with the business requirements. The C-suite is generally executing on the strategic priorities and delivering those throughout their teams. And the president or CEO is typically setting the mission and the vision. CFO and executive team is doing the funding. The priorities, again, come from the C-level. And then the line of business are responsible for executing and delivering projects and initiatives, and data teams own the capabilities. So this kind of shows the relationship between the data strategy coming from the top executive and the data teams and what's responsible. So that's the kind of value pyramid with data in organizations moving forward. Okay, so I put together a process that is centered around accelerating time to value for data. And this is essentially a blueprint. It can be followed in different ways, but it is a structured approach that should lead to more successful outcomes and ultimately value and insights from data assets. So I think I know the answer to this, but show of hands, who's actively working on a data project with your companies? Yep. Great. Who's had a successful data project that's really attributed to increased revenue streams or significant optimization across the company? Anyone? Show of hands. Okay, so a third, maybe a third at most. So that's the reality right now, is that a lot of people are working on data projects, and not too many are working on projects that are providing like substantial value to enterprises. But that's okay, because it's going to change. So Gartner, analyst firm, predicts that in the next couple of years, there'll be a lot more success in terms of value from projects, especially data teams that originate in IT departments, not so successful. That kind of goes back to the previous slide where data teams are decentralized across the organization, because there's more focus on use cases, there's more focus on business priorities, and it's not just like we're messing with data, we're dumping stuff into a data warehouse and trying to figure out what kind of insights we can get. So things should change. Okay, here's the time to value process, and I'm gonna walk around a little bit. The circular boxes are decision points, and the process kind of starts with a goal. And data strategy has to really come from the top down in most organizations, with some clear goals, some clear performance indicators. If you're starting a data project and executives are not aware of it, it's probably a red flag that you want to make sure that you're centered around like organizational priorities. Those are typically kept in the C-suite. So that's where we're going to start. And data strategy is essentially a roadmap of how to do this. I worked with a major hotel chain for the last 2.5 years at Google, and they moved all their customer data over to BigQuery, and that initiative took like 18 months and wrapped up in Q1 last year. That was before they started doing anything with GenAI or AI or anything at all. They really hadn't even had, like, just dumped everything, got all the pipelines going. But that was their roadmap. That was their data roadmap, first get everything over. And then last year they set up a center of excellence for AI. But they had already had everything set up in good order with their data and what they wanted to do around customer work. So that was their data strategy. I'll talk more about center of excellence in a little bit here. So data collection, and this is all a very iterative process as well. Collecting data, streamlining that whenever possible. I'll go over some accelerators on that. If you can use SaaS tools to streamline data collection, why not? Try to, again, I think also the key to this is not for perfection, but progress. So if you have an opportunity to integrate a SaaS tool, or I know Fivetran was here, it's a very popular like SaaS-based ETL tool, just to make things, get things over to a data warehouse sooner, why not use it? Exploration and preparation, this is a concept that's like very dear to my heart. I wrote a book last year on data exploration and preparation of BigQuery that I have here if anyone's interested in talking about it. But a lot of data teams can get bogged down with cleansing data, kind of looking for perfection. This is another area that data quality, there's data scientists and data engineers that all they work on is lineage and data quality, but this is also another major bottleneck in this process. Modeling and analysis, this is kind of where some of the insights start coming. And this also goes into like visualization and interpreting the data and communicating the data at different lines of business. And all going back to the original data strategy. Are we working on clear goals that are important to the enterprise? Are we working on goals that are important to the executives who are compensation is based on the company's growth and based on the projects that we're all doing in our roles? So this is the process, and we'll dive into it in the next couple slides here. Some critical decisions to help accelerate before we get into each specific one. Set and agree upon goals and prioritization. As practitioners, you have a say in this, okay? And I encourage pushback when leadership gives unrealistic goals. That could be because of my time at Google and having the flexibility to do that, but I would encourage you all to do that as well. If you're handed an unrealistic goal in terms of turning around, if you don't have the right resources to do that, instead of going into the dark unknown without the right resources or tools, speak up. Do data discovery and ranking. I worked with this, I mentioned a medical imaging company, and they still haven't gotten their data warehouse, data analytics efforts off the ground after 18 months. And they have a lot of really interesting radiology and healthcare data that they could actually be monetizing. They just haven't been able to do it because they have dozens of data sources, and it's like a daunting task for them. So start small. Start with the top 10 valuable data sources, and map those over to target, and get some ETL going, and get those moved over. Include budget approvers and stakeholders. Business analysts should definitely be involved, as well as line of business and budget approvers. It's very critical to have them plugged in, and that's what can be done in a center of excellence or in steering co-meetings. The right tools and partners, I mentioned earlier, like life cycle. I've worked on BigQuery for 4 or 5 years, and now the platform is just expanded tremendously, trying to keep up with the rest of the industry. So most enterprises land on a technology vendor and stay there for 3 to 5 years. Very common with Oracle. Oracle does a great job locking customers in, so it's 5, 7, 10 years sometimes with Oracle. But that's the reality. Unified data platform. This is what Databricks is doing right now. They have a really great data and AI platform where engineers, analysts, scientists, business users, everyone can be in a single place. And even services like BigQuery have pivoted to being more of a unified platform from this. So also, if you're leading data projects and you have some lofty goals from the executive and you don't have enough resources, consider bringing on a partner to augment resources and speaking up if you don't have that. I also encourage starting simple and iterating. If your enterprise is already a Microsoft shop, use the Microsoft tools. Most of the cloud tools for data are comparable and are usable across Amazon, Google, and Microsoft. So use what's already used, and don't use that as a bottleneck that you want to use a different tool. So be open to using those. Same thing goes with visualization tools. Most enterprises use Power BI, Tableau. You might as well use it and get familiar with it rather than going the uphill battle of going through procurement to use a different tool. And then lastly, I'm not talking too much about GenAI because I'm sure a lot of people talked about that today, but realistically manage the promise of AI to your leadership if you can, because I think that a lot of leaders really want the new fancy shiny promise of AI, but you can quote me on this, but AI should be a destination with data milestones ahead of it, right? You're not going to get too much from AI if you integrate an open or ChatGPT infobot. I don't know how much return or how much revenue more you're going to make from that, or how much customer satisfaction you're going to make from that. But the real value in GenAI and AI in general is once your data is figured out and models are actually using company data. Okay, so to-do list real quick. Create a center of excellence. If you're an executive, bring in different lines of business, budget approvals. That will cut down with some of the bottlenecks. If you're working in an industry, see what's been done already in the industry with data and AI. Why reinvent the wheel? Take a look and see what's happening in your industry with the specific use case that you're doing, and try to replicate it whenever you can. Prioritize the projects with the highest return on value. Set KPIs and time box goals. That hotel company that I was working with that moved all their customer data over to BigQuery, last year they set up a AI Center of Excellence, I think in Q1 or early Q2, and they said 8 months, a little bit over 2 quarters for them to start having some results and land on use cases. And it took them 8 to 10 months to get to actual use cases that would benefit their business and land on them through different pilots and different proof of concepts. Create a data-driven culture. I didn't talk about this that much, but as I mentioned, the decentralized nature of data teams moving forward, this should start to create the shift of a data-driven culture, once you have the lines of business involved and they can see the value that they can start gaining from having access to data, this should start to happen in most enterprises. But you have to do a couple things in order to do that. You have to set up self-serve tools for them to create their own visualizations. In many cases, set up self-serve like data prep tools, giving them access to different views and giving them access to different tables, democratizing data. I'm sure you've heard that at least once or twice this week. So that's a big deal in terms of being a data-forward enterprise. And then for practitioners, engineers, business analysts, scientists, like, use tools for automating, gathering, and cleaning data whenever possible. Like, don't get hung up on cleansing data. Again, progress, not perfection. Don't get bogged down by collecting irrelevant data. You don't really need everything. Like, start with a smaller set, and it's easier to analyze 5 tables versus 50. And break down projects into smaller chunks, and have quicker wins. All right, so some accelerators that I'll jump through here to help drive towards a data-driven culture and hopefully accelerate some of the different phases that you all are working in. Data strategy accelerators, again, this is mostly for executives. I suggest most executives to review analyst reports and work with what you have. So in the past, it was best of breed. You choose a cloud because of best of breed. Now, in terms of like accelerating time to value data, if you have Microsoft running in your organization, if you have AWS running in your organization, use those tools. Use what you have access to instead of fighting the battle. Same thing with visualization tools. I'll go over some prioritization frameworks, but data culture is a big deal for executives and data strategy. Data collection accelerators. Use industry-specific proven tools, right? If you're selecting a tool, and you have that opportunity, maybe use managed service instead of like writing Apache Beam code to do transformations. Give yourself a break. It's a nice lofty goal to be able to like adopt full open source tools, but sometimes the level of effort required to implement them isn't really going to provide the return or the time to value that you need. So it's nice in many cases to go open source because in theory it's very portable, but many of the SaaS providers don't provide too much lock-in anyways. API integration and automation, also important, and self-service approaches are going to help with data culture. Data exploration and preparation accelerators, a lot of self-service data prep tools and no-code data cleansing tools, especially with GenAI, it's becoming a lot easier to cleanse data and prepare data. Data profiling and metadata management also important in terms of like data democratization, semantic layer and different views you can roll out across line of business. Is a great project to get more people involved in the data culture. So as I mentioned, shameless plug here, last year I spent a couple months writing a book in data preparation and exploration and preparation of BigQuery. This has a lot of like fundamental concepts in it. I know there's only one person in this room that has an active BigQuery project, but if you're interested in, let me know, come say hi after this. But it was a great opportunity to do. Data modeling, I'm known to be a bit of a diagram diva. I really like creating diagrams, and it's equally important in data modeling to know what you're working with. So step back when you're working in analysis processes and make sure that you are building a diagram and you have the right relationships and entities, because you can typically spot things missing. So use some tools to do that. Data interpretation and communication. This is back to the line of business and actual data consumers in your organization. Tailor communication to the audience. Make sure you're giving people what they want to hear, right? A lot of times people in tech, they just like talking about the tech, right? And they're so excited about the tech. But think about who you're speaking to and what's important to them. That's something that I tell a lot of people that I mentor is like, think about what's important to your audience, or think about what's important to who you're speaking to, and kind of lead with that. and then things will land a lot better. But standard visualization tools across enterprises typically work for this. I think self-service BI is a big deal right now. Most business users should be able to navigate a spreadsheet and a visualization tool, or create documentation for them to do that. I think goes a long way in enabling people and getting more people on board in the data strategy. So roundup here, and this image was created with Gemini image gen. So establish a data culture. Self-service, as I mentioned, will definitely help time to value, get more people in the boat with you. Unified platform, breaking down silos. Governance and access is critical. Data quality, business user involvement. And then if you don't have the capabilities in-house, which most companies are short-staffed in terms of data teams, raise the flag that you need additional resources, and you can get projects done quicker with partners and different ISVs that are there to jump in the boat with you and help you row faster. Excuse me. So some anti-patterns. We all fall into these kind of pitfalls sometimes, time to time. I wanted to kind of highlight a couple of these, hopefully help some of you course correct and optimize. Rushing into implementation. Again, a lot of executives right now want to get to that end goal of GenAI implementation and get GenAI infused into all products. But if you skip the planning stages and don't identify actual clear goals that you're solving for, or have KPIs, or have measurement or anything like that, you're going to be just messing with technology and kind of burning cycles and burning valuable time for you to be get a competitive edge. Neglecting data quality. I mentioned progress, not perfection. We've all heard garbage in, garbage out. So prioritize data cleansing to a degree. Don't get kind of overwhelmed with it, where it could delay a project and hinder its values. But make sure that you have a reasonable degree of data quality, because that is critical to having good results. So strong data strategy should break down data silos and should break down lack of collaboration. This is the 5th or 6th time that I've mentioned this, but data culture and transitioning or making a company a data-forward company just requires collaboration. And there's tons of collaboration tools, and all the visualization tools can do that. It's turning on features and getting lines of business to use them. Focus on cool technologies over business value. This is another thing, it's shiny objects, right? We're all enamored by shiny objects, so I am at least. But focus back on business value, especially if you're spending the time, 8 hours a day working on a data project. Ask the question, what value is this providing to the business? And if you don't know what that is, you should definitely find that out. Okay, a couple other anti-patterns. Lifting and shifting. This is a very popular paradigm in cloud in the last 5 to 10 years. In my opinion, this doesn't really work well with data projects. It's basically moving over your on-prem data potentially to a cloud-based, but it's not providing any additional value, and it's probably more cost, if not the same cost, and not providing increased capabilities. So if you are going through a data modernization activity with your company, try to make some changes to pipelines, try to make some changes to schemas, what you're doing, how you're processing data, how you're cleaning data, adopting new tools. Don't just move everything over as is. A lot of executives still have the goal of being 100% cloud or getting out of data centers, but I encourage some modernization when you do that move, because it's the same thing but different. Okay, some frameworks and architectures to wrap up here. These are some approaches to consider to avoid roadblocks and pitfalls, better understand use case priority. Value translation framework. This is a really simple framework and exercise that we go over with customers in value workshops, where we try and understand the strategic priority, the business challenge and the priority, and what technical solution it's going to drive, and what value it's going to present. So for those of you that are currently working on data projects, they're not completed successfully, and you want to get to that, you may consider utilizing a framework like this. It starts with what's the business context and what challenge are you addressing? what are the root technical capabilities that would lead to solving the challenge, and then how does it impact? So here's an example. This company has an overstock of products, company that's managing inventory, right? Really great use case for data project. They have overstock of product and logistic budget that is in excess and needs to be optimized. But the data team is not able to get to it because they're running a backlog, and there's a pipeline that is breaking and not providing good data to supply chain analysts. So this is a perfect example of a high-value data project, namely fixing the pipelines that are getting the data over to be analyzed and spending however many hours or dollars to fix those pipelines to provide better data to the business to have a better expense and cost on their product stock and logistics. So by improving the broken pipeline that takes days to rectify and reconfiguring it and implementing lineage and spending the time to do that, could be weeks, could be tens of thousands of dollars, there's a significant cost savings to the business. That's the value opportunity. So that would be a very high value data project from my view. Fixing the pipelines that are breaking, that are not delivering accurate data, and then ultimately fixing demand forecasting. So that's a data engineering team project that would be a really great win for any company. So that's the value translation framework example, and this is a very simple exercise that we go through in workshops with companies. So you see there's KPIs, like by fixing the broken data pipeline as a less than a 1% failure, whereas before the pipelines would fail daily and have to be manually restarted and delivered lousy data to business analysts and analyst teams. It now takes minutes to fix instead of days, or it doesn't break at all. So high value. Thinking about technical improvements, having more volume, increased data availability across line of businesses. These are high value data projects. Improve reliability, model accuracy, reduce time to market, scale. Then business benefits could be reduced tooling or support costs, lower data processing costs. When I would design, or my team would design a analytics solution for customers, we would always, and this is just the nature of enterprise cloud, we would always try to make the cost neutral, meaning they're going to be spending $100,000 a year on BigQuery and Dataflow and Dataproc for processing and Looker for visualizations, but we've identified a use case that's going to save them $300,000, $500,000 a year, and we're going to help them implement that. So the infrastructure costs and the cost to operate the solution, the cost savings make it irrelevant, and it's like a no-brainer for adoption. Also, what we tried a lot, or what we did a lot, and this is just normal enterprise cloud architecture and pre-sales, is new revenue streams. So, okay, customer comes to us and says we have all these data sets. We're working in this industry, this regulated industry, healthcare, and we get with our healthcare team and we say, wow, you're sitting on a gold mine right now. Have you thought about monetizing that data? And we work with them to create a data product, which is a lot of organizations are going to now with different architectures like data mesh that are enabling that. So we're creating this architecture for them, and they're spending this money on this infrastructure, but then ultimately they have a potential new product line and new product revenue stream. I think once companies can get to that, it's kind of like the holy grail. We're data forward, we're making more money off of our data, and everyone's happy. And the data engineers and science, the data engineers and scientists are like the heroes, right? And it's not far-fetched. Like, it's very possible. This is another framework. It's called the ICE framework. It's for use case prioritization. Another thing, that hotel company that I mentioned earlier, is they had like 12, 15 use cases for GenAI. And they were just like, travel planner, sounds pretty good, right? Natural language search, I really wanted them to do that one. Like, when you search for a hotel, right, it's usually city or zip code. There's like 2 things that you do. But wouldn't it be nice if you could search like 5-star hotels under $800 a month in the Miami Open weekend, and give me some restaurants, some Michelin star restaurants around the neighborhood? And then it does that. GenAI can do that. That was like one of the initiatives. But I'm sharing this with you because most organizations like have all these like use cases that they want to do, and then they get like enamored and bogged down because it's tough to like do pilots or proof of concepts on 15 different use cases. So this ICE framework helps you prioritize use cases. And this is like a standard framework. It's not specifically for data, but it can provide a lot of value and help with some prioritization. So there's ICE. That's the ICE graphic that I created with ImageGen, Gemini on Google. ICE allows for the fundamental elements to prioritize use cases. So impact, confidence, and ease. Again, level of effort, ease. How quickly can you do this? How quickly can you do it? How confident are you? And this is an exercise that data strategy owners, executives need to be plugged in with, or at least like VPs and directors that are owning data strategy need to be plugged in with this. But this helps you articulate the value and helps you prioritize use cases and cut through to what's actually meaningful and allows you to spend your time on that. So very simple scoring on this, right? How high is the impact? And this is also a questionnaire that I've seen different center of excellences, like AI center of excellences and steering committees go through. And they'll literally pass this around or do it in a sheet, like collaboratively. Do you strongly agree? And they can kind of weed through different use cases in a really short amount of time. So there are ways to score and prioritize use cases that I definitely recommend. This one's called ICE. And I left off a slide here, but after you do this, you can like do a scatter plot, and like you can see like what's ranked the highest, and then you leave that meeting with like, we just had 15 use cases, and we've like wound it down to like 3 have the highest impact and ease of implementation. Let's go forward with these 3, and let's try to do these in 6 months, and let's see if we need additional resources to do this. Maybe we can get like 50 grand from our cloud vendor to help fund the work. So, okay, let's go to a couple architectures and we'll wrap up here. Data mesh architecture. This has been around for like a couple of years here now, and this is definitely not too many companies have data mesh going. We worked with a major financial company that was very public with their Google Cloud usage, and they had data fabric. Has everyone in the room heard of a data fabric architecture? Yeah. So they had one of the first like data fabric architectures and data mesh architectures, but this is like more for very mature customers that are in that data forward like paradigm. They've already broke down the silos. They've already got line of business engaged, and now they're able to create different data products and start to monetize. Data products for internal usage, data products for external usage. The data mesh architecture definitely enables data product thinking, which should be more prevalent in the next couple months and this year. And that's underpinned, obviously, by metadata security, governance, observability across the organization. A couple more last architectures to leave you with. I'd be remiss if I didn't mention Lakehouse, now that I'm currently working with Databricks. Lakehouse is the combination of data lakes and data warehouses. BigQuery traditionally being a data warehouse platform for the last 10 plus years. Databricks started off as a lakehouse, combines the paradigm of data lakes and data warehouse, which is a little bit more flexible for unstructured, structured data and managing different types of data across the organization, different roles. So that's something to consider if you're adopting a new data management platform. Event-driven architectures, these have been around for a while. A very common one that we would do at Google are like drop a flat file into a cloud storage bucket, and then it triggers off a function that appends rows to a table. So anything you can do event-driven that will expedite the ingestion of data and make your life easier, it should be adopted. And then I know our last amazing discussion was centered around data ops. This is another very emerging field that kind of takes a feather from DevOps, which was very prevalent in application development over the last couple of years. But we're starting to see a lot of these patterns that have been going around for a while that are popping up in AI and data. And data ops is very important to consider, even if you're just considering like governance strategy but for the more mature, more enterprises and having like governance and standard practice around data pipelines, data ops is something to consider architecture-wise. So two or three more slides here. Now I just wanted to talk a little bit about what the lakehouse looks like and what the data intelligence platform looks like. So data intelligence is essentially like integrating GenAI tools across the data landscape and allowing GenAI to kind of power and streamline some of the different efforts. So in this situation in Lakehouse, this is the traditional Databricks deployment. We now have an intelligence engine that is helping with data semantics, that's helping with orchestration workflows, as well as data layers. So all of this is kind of feeding upward and is kind of assisting the different processes that we talked about earlier. So you're seeing this pop up in all different cloud vendors. Google has it as well. So we're kind of seeing the shift from lakehouse, data warehouse to overall intelligence platform. So additional complexity for all of us to manage. This is a really quick architecture example of a customer implementation of Delta Lake and Delta sharing and Databricks with Azure. So the customer has two data feeds on the left-hand side, API and SFTP files. They're moving SFTP files to blob storage via event-driven, most likely. And then they have a couple different degrees of data lakes that they're running on top of, or Delta lakes that they're running on top of Azure infrastructure and processing it with Spark on Databricks. So this kind of shows you how you can integrate data science and ML on a single platform with a single cloud vendor and leverage existing visualization tools to do that. Okay, that takes us to the end of the presentation. Thank you all for being here. Thanks for hearing me out on accelerating time to value for data projects. If you have any questions, feel free to reach out or let's chat after I get off the podium. Or find me on LinkedIn, and I'd love to connect with you all. And thank you very much.